Hello everyone. In this video, we will see that how electric fields due to circular wire and straight wire are equal. We will also understand that how these concepts make some of the very difficult questions seem very easy, and also it will make your problem solving a bit more fun. So without wasting any time, let's move on to the solution. Okay, so to prove our point, I'm taking this straight wire AB and we will be finding the electric field at point P. To find the point electric field at point P, first we must take a very small section somewhere here at a distance L from this point. We'll call this point as O. The length of this section, I've taken it to be equal to dl. It will be dl only. And then I'll join this. The distance of this section from the point P, I've taken it to be z. Now, this section is at an angle theta with this line PO and subtends an angle d theta at the center. I'll write down some of the geometrical relations between them, which will be useful. So L equals R tan theta. Okay, I forgot to write the R. Actually, R is this distance. Next, Z will be equal to R sec theta. The charge on this section will be equal to lambda into dl, charge per unit length multiplied by the length. Now using Coulomb's law, I can write that the small electric field due to this particular section will be K is the Coulomb constant, dq, charge on the section, divided by distance squared, which is z squared. If I put all the values, it will look something like this. K lambda dl divided by r square sec square theta. Now I want to write down this expression only in terms of theta. Theta should be the only variable. So I'll replace the value of dl, but for that I have to differentiate this relation. So differential of L is dl, and this will be r sec square theta d theta. Again, replacing that value, I'll be left with k lambda r sec square theta d theta divided by r square sec square theta. Now simplifying all this r will be cancelled, sec square theta cancelled. This will be k lambda by r 4 multiplied by d theta. So quantities in this bracket are constant for this particular situation. Lambda will not change, this r also will not change. Now we can integrate this relation to find what will be the net electric field at this point. But actually that was not our question. Our question was to show that field due to straight wire and circular wire are equal. For that, I'll take a circular arc of radius r. This should be the radius, and center is at point P. And I'll try to draw it as neatly as possible. So I think I've done a good job here. This is the best I can do. So, and we will try to find the electric field due to this particular section. We will take that the charge per unit length on both the wires are equal. So this also has lambda charge per unit length. The length of this section will depend upon the angle it subtends and the radius of the arc. So the length will be rd theta. Now electric field due to this circular section will be equal to, again we will apply Coulomb's law, K dq. Here dq, now the charge will be on this section and the charge will be equal to lambda r d theta. And I have to divide it by the distance squared. So the distance will be from here, from this section to this point P. So that distance is obviously r because there is a circular arc of radius r. Simplifying this, you will get k lambda by r times d theta. As you can see, you are getting the same result. So now what we can say further? We can say that since this section of a straight wire makes the electric field which is exactly identical to this particular section of a circular wire. And you can also see that for each section there will be a corresponding unique section on this circular wire. Let me repeat it. For each section of the straight wire there will be a corresponding and unique small section on this circular wire. And since this is a generalized result, this pair will make equal amount of electric field. Their direction will also be equal. So for this complete wire from A to B, if you draw these lines, this can be thought of as the angle subtended by this wire AB on B. If you draw these lines and make an arc of radius r centered at P, which are getting intersected by these lines PB and PA. All the sections from here to here on wire AB will have their counterparts on this particular arc. Let's call this point as C and this point as D. Since all of them will be making equal amount of electric fields, the total electric field due to wire AB will be equal to total electric field due to wire CD. Hence, we can say electrostatic field due to straight wire AB and circular wire CD is equal at point P. So guys, these are the few points I have written here which you must take from this video. Charge per unit length of both the wires must be equal. Straight wire must be tangential to the circular wire. We have already seen that. And the only point for which the circular wire and the straight wire will have same value of electrostatic field is the center of circular wire. Now, if you understood all these concepts, I think you should try a question. The question here asks, electric field at some point dash blank of any triangular wire of constant linear charge density is 0. So you have to identify which of the points will have 0 electric field. Centroid, circumcenter, in-center, or a little less known point is also there, which is called 9-point center. Please answer in the comments. I hope you enjoyed the video and you understood the solution. Thank you.